three sections we have to cover today. First section is section 2.1, called linear equations in two variables. We're going to be talking about x and y today. We'll look at equations where they affect each other. So just to get started as a baseline, let's talk about what a solution to an equation means. So a solution to an equation just means that numbers you can plug in and have it make sense. Typically, when we're dealing with an equation, especially in this section, we have an x and a y value. Just make sure that you write them correctly. X comes before y, just like in the alphabet. And when we go to graph it, the x-axis goes horizontally and the y-axis goes vertically. When I was in grad school, I had a professor that said that y goes to the sky. So hopefully you can remember that the y-axis goes up and down. What I'd like to do first is let's complete the order pairs for 3x minus 4y is equal to 12. So I have four of them. First one is, let's say we have 0 and then a blank. What this is saying is when x is 0, what is y? All we have to do is just plug 0 in for x. 3 times 0 minus 4y equals 12. We solved equations in our last class. 3 times 0 cancels, it's just 0. Negative 4y would be 12. Divide by negative 4, get y is equal to negative 3. That's what would go in our blank spot over there. We had a blank and then 0. What this is asking you is when y is 0, what is x? So when y is 0, what is x? So let's go ahead and put 0 in for y. Just be 3x is equal to 12. If you divide by 3, you get x is equal to 4. We'll talk about this a little bit later, but when x is 0, this is called a Y-intercept. Y-intercept just means what do you get when x is equal to 0? When y is 0, this is an x-intercept. If you notice, they're opposites. So if you want to get what's called the y-intercept, we'll talk about what that means later. If you want to get the y-intercept, you put 0 in for x. If you want to get the x-intercept, you put 0 in for y. Example. What about if we had -6, comma, let me just have a blank here. What this is asking you for is when x is -6, what is y? We take our same equation. X is -6. So multiply and be -18. Just add 18 on both sides to try to get y by itself. Divide by -4. Get a fraction that reduces to -15/2. Second, make sure you have that copied down. All right. So when we get to the intercepts, which I had talked about before, when we talk about an intercept, this is just where a line crosses an axis. What this means is if we were to draw a coordinate plane, remember y goes to the sky, and this is our x-axis. An x-intercept would be when y equals 0, and it would cross the x-axis somewhere along that horizontal line. Similarly, with a y-intercept, if we, this is the y-intercept, if we set x equal to 0, that would be where the graph crosses the y-axis. So you will have a problem like this on your exam. So let me show you what the problem will look like. We'll say find the x and y intercepts for 2x minus y equals 4. Remember, they're always opposites. So if you want to find the x-intercept, what this means is you make y equal to 0. If you want to find the y-intercept, all you have to do is just put 0 in for x. Let's go ahead and do this. If we put 0 in for y for the x-intercept, we get 2x minus 0 is equal to 4. 2x would equal 4, and if you divide by 2, you get x is equal to 2. That means the graph crosses the axis right here when x is 2. That's the x-intercept, that's where it crosses that line. If the y-intercept is 0, we plug in 0 for x. This will just be 2 times 0 minus y is equal to 4. Times 0 cancels, we just get negative y is equal to 4. We divide both sides by negative 1, we get y is equal to negative 4. On the test, I will ask you to graph it. I mean, how can I make it any easier than that? You just connect the dots, right? We have an x-intercept, we have the y-intercept, connect the dots, and you get a line that looks like that. The only way it could get a little bit harder is if you had a similar problem where I asked you to graph 3x plus y is equal to 0. Finding the intercepts is generally the easiest way to graph an equation. But if we do the same process and we look for an x-intercept by making y 0, and a y-intercept by making x 0, put 0 in for y, we get 3x is 0, so x would be 0. X is 0, we just put a point over here, it crosses the x-axis is 0. The y-intercept, we put a 0 in for x, just get y is 0. We only have one point. So this is where it gets like a little tricky, and we'll talk about slope in the next section. But if you wind up with a problem and the intercepts don't help you graph it, as a backup plan, you just pick a random x and plug in for y. So for example, just pick a random x value. Somebody just yell out an x value, random number. 12 I heard? All right, I heard 12 first. So random number, I heard 12. What we're going to do is we're going to plug that into the equation 3x plus y equals 0. You could have picked any number, right? So generally, we try to pick smaller numbers, but 12 will be just fine. 12 for x. We do 3 times 12 plus y is equal to 0. 3 times 12 is 36. And if we subtract that on both sides, we get y is equal to negative 36. So we couldn't graph the line before, but by picking a random x value, we get a point when x is 12 and y is negative 36. This would be the point 12, negative 36. And the line would look something like this. In the test, it'll work out. You're not going to have something equals 0. It'll be similar to the first example. Speaking of unique looking lines, like if you have it equal to 0, that's a little bit of a different case. Sometimes you wind up with a horizontal line or a vertical line. All horizontal lines can be written y equals the number. It's really important that you remember that. We'll mix this up all the time. We'll learn about slope in the next section, but the slope of these lines would equal 0. Once we finish class today, you'll understand how it all fits together. All vertical lines can be written x equals whatever. We say that the slope is undefined. Graph. You ever have a vertical line like this? This would have the equation x equals whatever number. You have a horizontal line. This would be y equals whatever. It's really important that you get that. I had one other type of problem to finish out this section. Before we get to that, what would be the x-intercept for this line? Where does this cross the x-axis? It never does, right? This green line never touches the x-axis. It's possible when you have a line to have none of the other intercepts. I wanted to finish off this section by talking about something called midpoint. To find a midpoint, we take the average of the x and y values. Formula for midpoint would be you add the two x values together, you divide by 2, and you add the two y values together and divide by 2. A couple examples with this before we move on. If I asked you to find the midpoint of P2, if P is -5, 8, and Q is 2, 4. Have 2 points, this would be x1 and y1. This would be x2 and y2. And then we just have to use the formula for a midpoint. Midpoint would just be take the x values and add them together, divide by 2. Take the y values, divide by 2. We do that, -5 plus 2 is just -3/2. You're allowed to have fractions, so just follow the formula, add them up and divide by 2. And 8 plus 4 is 12. 12 divided by 2 is 6. The last problem from this section. What if I asked you to find the endpoint point P is 2, 3, and the midpoint is 5, comma, negative 2. So really, the best way to do this is just to graph it out, like I'm doing right here. We know point P is 2, comma, 3. Midpoint is 5, comma, negative 2. We don't know what Q is. That's different than the last problem we just did. Previous problem, we knew point P was negative 5, comma, 8. We knew point Q was 2, 4, and we were looking for the midpoint. See what the difference is? The difference now is we don't have the other endpoint. This problem is really easy, though. If that point in the middle is the midpoint, what we could do is just count to go from one coordinate to the next. So what do you have to do to 2 to get 5? So we add 3. To go from 5 to this point, we just add 3 again. To go from 3 to negative 2, you have to do minus 5, right? And then to go from minus 2 to this one, again, we just subtract 5, which would be negative 7.